Ucore Rare Metals, UCU on the TSX Venture Exchange, has developed a technology for the separation of rare earth elements. Should the company be successful in the commercialization of this technology called RapidSX, it would be one of the very few players in this area outside of China. The importance of this cannot be stressed enough and has obviously been recognized by the Canadian government too. We want to hear more on that from Ucore-CEO Pat Ryan. Welcome back to GOLDINVEST, Pat.
Hey, great to be here.
So, Pat, before we talk about Ucore's most recent news, please give us a 30-second snapshot about what the company's mission is for all those viewers as yet unfamiliar with the company.
Yeah, within the 21st century green energy transition, a lot of critical minerals are needed. We hear a lot of talk about, lithium and cobalt and things needed for batteries. But you also need rare earth, and rare earth is very important to the electrification of vehicles. It goes into permanent magnets that drive the electric motor. It goes into wind turbines for offshore, wind generation and defense applications. An F-35 fighter in the U.S. has 920 pounds of rare earth, and that's controlled by China. And so Ucore is very focused on the separation of the critical rare earth oxides, which are the seeds of technology that they call it, that allow you to make metals and alloys and permanent magnets. So very fixated on breaking the grip of China and getting this done for the Western world.
Okay, so that's probably why, or not probably, that's I'm sure why the Canadian government now decided to grant Ucore more than $4 million to demonstrate the commercial efficiency of the company's RapidSX technology. I think specifically for light rare earth elements in that case, in your demonstration plant in Kingston. Can you tell us more about what that involves and what that additional money will allow you to do that you could perhaps not otherwise have done?
Yeah, no, absolutely. The Canadian government has put forward a couple of very robust programs in the billions of dollars for critical mineral processing. On the rare earth front, there are a number of up-and-coming resources in Canada that are rare earth resources. However, you can't do anything with the resource to concentrate unless you're able to separate it into the individual usable oxides. And currently, 85-90% of that separation resides in China. So the Canadian government came to our demonstration plant in Kingston. They saw what we were doing. They saw that the RapidSX technology was a very westernized approach to separating out these oxides. They liked what they saw. They liked the ESG component, which meant less chemicals, less reagents, less power, less people touch time, a lot of automation, 50% less labor than what you'd find in a solvent extraction plant, a column-based patent pending technology, which is much more space friendly than you'd have in China. It's got a better OPEX and a throughput. So the Canadian government said, you know what, for light rare earth processing, we'd like to use this technology and we'd like to have you rigorously run your plant for thousands of hours and show the separation to NdPr and NdPr compound, which are inputs on the light rare earth side used for permanent magnets. And without those, you can't make a permanent magnet. So yeah, they're looking at the bigger picture. We've got resources, but they need that critical separation. They liked our technology and they've put forth a contribution agreement of 4.28 million Canadian, and we'll use all of it to take our technology to a higher level of commercial readiness.
So that's so to speak, you're gathering more data on what how the process is run, how the efficiency is and stuff like that.
Yeah, very much. Again, very rigorous trials. You're going from what they call a technology readiness level 7 up to a technology readiness level 8, which means you're ready for commercialization. So you're getting lots of metrics. You're running the system and you're running it flat out, and you're running it around the clock, and you're running it for 6 months straight, separating out highly purified light rare earth oxides. And so that's the proven test of being able to then get to the commercial level, which the engineering for that is currently going on. The plant layouts are being developed and the chemical processing layouts are being developed to take what we're doing in Kingston and plugging it into a much bigger commercial facility. So yeah, the program's very rigorous. We've got 3 different feedstocks that we're using to trial through the plant, and the Canadian government is supporting all of it.
Okay, let's talk a bit more about what the schedule is. You talked about like running the plant for 6 months continuous, for example, on this program alone, when will that start? How long will it be exactly 6 months? How long will it? What's the schedule, so to speak?
Well, in December, we'll be procuring what they call a neutralization and distillation equipment. That's part of the process. We're fine-tuning all the PLCs, the pumps, and the column tech right now. So that's part of what's going on currently. And the Canadian government is funding that. We'll actually start to run the campaign somewhere into the second quarter of 24. And one might ask, well, why wouldn't you start right away? The reason is that we've got to procure the feedstock, which is actually underway now. But we also have a program with the US DoD, and the US DoD is focused on heavy rare earth. So terbium and dysprosium and everything involved with the high heavy side of making a permanent magnet. And that campaign is first to run through our plant. So we're running the DoD US program first, and then we'll start the Canadian program and run that for 6 months to produce the lights that are required as well. So 2 programs working in tandem, and the equipment is very multifunctional, so we can run everything on one set of equipment, but we've got to start with the US DoD. That award came out several months ago, and we've committed to a schedule with the US government for that.
Okay, yeah, well, that shows a high level of confidence in your technology. I'd say that now governments from 2 nations are trusting you, and also the US government also gave you, I think, $4 million in that case to do that work.
Yeah, very much. And the governments don't just write agreements and hand them out to anyone. They do a lot of due diligence. And on the US side, we had a lot of high-level due diligence. We had people that came to the Kingston plant, took a look at what we were doing. The same thing on the Canadian side. Canadian government officials came in, took a look, saw the independent evaluations we had done to date, looked at what we were running through the plant, looked at the setup, all the metrics we were gathering, and doing a comparison to traditional solvent extraction as well. So part of our program, both for the US and Canada, is to show the increased throughput, the reduced capex, the better operating parameters from an ESG standpoint, and all of that happening by comparing it to a conventional solvent extraction system. And that is the only process used in the world right now by China to separate out. So we're making sure that all those metrics are dialed in. But yeah, very, very high level due diligence to ensure that the investments that were being made, both by the Canadian and the US governments, were on point. So yeah, very, very, very rigorous, and we came out on top. So
that's great. So that program is running now and will run into the next year, followed by then the work for the Canadian government. Now, all this, and you alluded to that already, is of course in means to an end, that is commercialization. And I think you already picked a site for that in Louisiana in the US. And I think then we can safely say, it's safe to say that you're going to transfer all that technology and the knowledge that you gain from what you're doing there now to Louisiana, and then build it up on a bigger scale. Can you tell us a bit about that? What's the plan there and how that is progressing?
Yeah, very much. We did a lot of due diligence starting in April of 22. The state of Louisiana had identified about 20 buildings that we'll call brownfield buildings. We didn't want to build a building from scratch. They identified 20 sites that potentially could take the RapidSX technology and plug it in or do a copy and paste from Kingston. We ended up in Alexandria, Louisiana. Really good economic conditions there, great supports from the universities. So you've got up and coming engineers and metallurgists and whatnot that can feed into your plant. Very good transportation metrics and whatnot. So that's where we ended up. So currently, the team that's been working on the RapidSX demonstration plant in Kingston is working on the full-scale engineering for Louisiana. So people like MechChem out of New England, they build chemical processing plants. They've been doing the layout for the Louisiana facility. Orbital Engineering out of Pittsburgh, they build big energy plants all across North America, and they too are involved with the design and the engineering of the facility in Louisiana. Everything from looking at hydrochloric acid recycling systems, fume scrubber systems, making sure the chemical reagent ESG template is what it needs to be. All sorts of very high-level engineering, laying out 3 light rare earth lines, 3 heavy rare earth lines, and a ramp-up plan going from 2,000 ton per annum ex-cerium, ex-yttrium at the outset, up to 5,000 ton, up to 7,500 ton. And the engineers get really wound up in the ramp up plan and the tonnage and the throughput. And I remind them all at the end of the day, I said, look, that 7,500 ton plant, when it's up and running, that's 3.8 million electric vehicles. And it's also 7,500 Haliade-X wind energy turbines that would power 120 million homes. In the US, there are 140 million homes. So very substantial contribution to the green economy, and all the engineering is going on because, you've got to take your work in Kingston and plug it into commercial readiness. That's what Louisiana is all about.
Okay, well, thanks for the update there. So we covered some bases there, but what can we expect apart from that kind of news flow in the next weeks and months, let's say?
Well, a number of things. Obviously, we'll give updates on the programs that are running in the Kingston plant. So you'll have news about purified product and quantities produced. And then the whole idea is to produce those purified quantities of the lights and the heavies that will allow you to then qualify for, say, an electric vehicle company. And so you're getting specified product for an electric vehicle company. There'll be news of that type of product moving forward, or news of that type of purified product moving forward. You'll also have more news about the development of the construction in Louisiana and what's going on there. And furthermore, we're working on what they call pre-purchase supply agreements, which are sort of an offtake approach. So end customers are looking at our plant, they realize they need these inputs, and we're negotiating with a couple what we'll call a pre-purchase supply agreement that gives a discount to product over a certain period of time. And that news will be flowing too in the upcoming months, where we'll show which customers are lining up to use the product that Louisiana will ultimately produce. And last, I think further government program funding. These programs, both in Canada and the US in particular, it's an OTA, other transaction agreement. It means that once you get your tranches of activity and milestones achieved, more funding is able to come your way. And the US is currently looking at the Louisiana facility and saying, okay, Kingston, tick that box. Now let's look at Louisiana and figure out how we make that happen. And likewise for Canada, they want to run their program, and they would love to have SMC, Strategic Metals Complex, as we call it, back in Canada. So further government news, stay tuned.
Okay, well, that sounds great. So all in all, we could say that now is a good point in time to look closer at Ucore if you haven't already, and to stay tuned on what's coming.
Yeah, absolutely. We consider that we're we're very undervalued in the market given what we're doing. A couple of breaks in news here will certainly show our direction and our fortitude to get the full job done. And these government awards, that's not a small issue. That's two governments stepping up and saying, hey, let's work together and get this funded for North America, for the Western world. And we're excited by it. So currently undervalued. We think it's a great buy.
Okay. Thank you very much for taking the time talking to us. And we'll be sure to talk again, perhaps if one or the other news comes out. Thank you.
Thank you.